So welcome all for this presentation. So the topic for this session is timer counter in 8051, serial communication in 8051 and interrupt in 8051. First let us discuss about timers and counters and then serial communication and then interrupt. So in 8051 we have two 16-bit timers T0 and T1 works as a up counter, and T0 T1 is further divided into 8 bits of registers TH0 and TL0 and TH1 and TL1, and T0 and T1 counts internal clock pulse, and we will be calling it as a timer, and when it counts the external clock pulse, then we will be calling it as a counter. So when you utilize the internal clock pulse of 8051 microcontroller, it acts as a timer, and when you make use of external clock pulse, then it acts as a counter. So for this purpose we will be utilizing two registers, T-count register and T-mode register. So first let us discuss on T-mode register. So it is a timer mode control register which is of 8 bits. So here M0, M1, C/T bar and gate, this will be utilized when you choose timer 0, and M0, M1 /T bar gate will be utilized when you choose timer 1, and here T bar/C, that will be defining whether you are going to choose counter or timer. If your C/T bar, if it is 1, it will be acting as a counter. If it is 0, it will be acting as a timer. Right. So set 1 and it acts as a counter, and if you make it to 0, it will be acting as a timer. So if you want to make it as a counter, we need to apply external frequency to T1 or and T0, and if you want to make use as a timer, then we can make use of the internal clock frequency over here. And gate, it enables the control bit, so it will be set to 1 if you have timer controlled by an hardware signal which is INTX signal. So you have two hardware signal over here, INT0 and INT1 are the two hardware interrupt signal. So if it is the case, your gate will be made to 1 or else it will be made to 0, and M0 and M1 are the mode control bit. If your M1 and M0 is 0 0, then it acts as a timer mode 0, and if it is 0 1, timer mode 1, if it is 1 0, timer mode 2, if it is 1 1, timer mode 3. And your next register is T-count register. So it is bit addressable. It has tcon.0 to tcon.7, and here TF1 and TF0 is a timer overflow flag, and this flag will be set to 1 when your timer starts overflow, when it occurs when it is rolling over to all 0, and when it will be 0 when the processor starts executing ISR after overflow. And TR1 and TR0 is a timer run control bit, and this bit will be made to 1 when you start counting, and it will be made to 0 when it stops counting. So counting, when it is started, this bit should be made to 1, and if you want to end, then it should be made to 0. IE1 and IE0 are the external interrupt bit. So I told you have two external interrupts over here, hardware interrupts, INT1 and INT0. So it will be set to 1 if you have an interrupts from INT1 and INT0, and it will be made to clear to 0 when ISR is executed for this particular interrupt. So INT1 and INT0 is an external interrupt type bit, so it will be set to 1 when it experienced INT1 and INT0 pin with negative edge triggered, it will be made to 0 when your INT1 and INT0 it is low level triggered. And next let us discuss how it works. So as I told earlier, 8051 has a 216-bit timer T0 and T1, and it works up counter. So T0 has been divided into TH0, TL0, and T1 has been divided into TH1 and TL2 of 88 bits. So timer or up counters, and for a given clock it will be increment by 1. So when it reaches FFFF, it will roll back to 0000, and during that it will generate timer overflow interrupt what we have discussed earlier. So count will be calculated with this formula. Count is equal to FFFF minus the value what you are going to count plus 1. So for an example here, if your count value is 9, so FFFF minus 1 plus 1, which gives you FFF7. And when you load this to TH0 and TL1, when you move this value to this value, which is the hexadecimal value, from there it starts counting, and when it reaches FFF, it will roll back and it will go to 00000, which reflects on TF flag, TF register. So this counter loads to T0 or T1, which will be incremented after every clock. So whether it is a timer or a clock, a counter, as I told earlier, so when you make use of the internal clock of 8051, it will act as a timer. When you make use of the external clock, it will be acting as a counter, right? So for that we need to configure TMO register what we have discussed earlier, and there we will be choosing whether we are going to make use of that as a timer or a counter. We need to configure those register. So how it works? So load the counter, load count in T0 or T1, what we have did here for a count 9, and it will be incremented after every clock pulse. Once it reaches the value FFFFF, and it will roll back to the value 11111. So it will make TF0 or TF1 bit to 0. If you choose timer 0, then TF0 will be made 1. If you choose timer 1, TF1 will be made to 1. Then it leads to an interrupt to 8051 microcontroller. Then it go back, it service the routine over here, and then after completing the interrupt service routine, after executing this instruction RETI, it comes back to the main program. So this is a working of timer or counter in 8051 microcontroller, and these two registers we have discussed already. So here this is the point where we will be choosing whether it is a counter or a timer. So if it is 0, it acts as a timer. If it is a 1, it acts as a counter. And this particular switch, so when it is closed, there will be an output where it starts counting. So if this switch want to be closed, the output from this gate should be 1, and TR0 or TR1. So TR0 and TR1, so this pin will be 1. So when you get external interrupt from interrupt pin INT0 or INT1, this will be made to 1, and if it is a case, gate bit will be 1, and output of this NOT gate will be 0, and this is a OR gate. So 1 plus 0, it will be 1. So already TR0 and TR1, if you choose any one of this, it will be 1. 1 into 1, it will be 1. Then it starts close and start its counting process. And it is a programming aspects for timer in 8051 microcontroller. So the program is write a program to generate a delay of 20 microsecond and send a logic 1 to port 2.0. Assume your frequency for this 8051 is 12 megahertz. So these two registers we have discussed already. So we have chosen timer 0 with mode 1 in a 16-bit timer. So if it is a case, first 4. This, since we have chosen timer 0, this 4 bits for timer 1 will be 0, and here we have chosen mode 1. So in mode 1 your M0 will be 1 and M1 will be 0, and since we are chosen timer, we are going to provide internal clock pulse of 12 MHz. This bit C/T bar will be 0 and your gate pin bit will be 0. So 4 zeros and 3 zeros followed by 1, and bit specifies bit addressable. And to start the timer with mode 1, so to start the timer with mode 1, this TR0 bit will be made to 1 and the remaining things will be made 0. To stop the timer 0 with mode 1, this will be made, TR0 will be made 0. So 4 zeros and followed by 4 zeros with which is bit addressable. To calculate the count, one count time is equal to 12 divided by FOAC, where FOAC is 12 MHz, which gives you 1 microsecond. And so for a value count of 20 microsecond, so your x value, it will be 20 and your x value is 14 in terms of hexadecimal. So now your count, as per the formula what we discussed earlier, your count is equal to f minus 14 plus 1. So the answer will be FFEC. This will be loaded to your TL0 and TH0 register, which is of 88 bits, and from there the count starts, and when it reaches FFFF, it roll backs to 0. So this is a program related to that. So 7 zeros and 1s. So we have chosen timer 0 and mode 1, and for that this is a configuration, and we are moving that into T mode, and this is a value we have calculated for a count. So EC moved to TL0, FF has been moved to TH0. So this is a value, and then we have started the timer by using this configuration, and we have waited for some second so that it reaches FFFFF, and then it roll backs, and after that the logic 1 has been moved to port 2.0 as per the question. Then it stopped the process, and then it ends the program by using simple jump here. So the loop will be keep on moving over here.